Imagine an empty void, just infinite space, and two straight lines drifting right through it, completely ignoring each other. Eventually, their paths cross. They meet at a single point, creating an open angle. But no matter how long these two lines extend, they can never enclose a space. The area between them just spills out into the void. To actually capture space, we have to enter the world of polygons, and the rule for entry is strict. A shape must be completely closed, and it must be built entirely out of perfectly straight lines. Look at this circle being drawn. It completely traps space, but because it relies on a continuous curve instead of intercepting straight segments, geometry mathematically rejects it from the polygon family. So if two lines leave the shape open and curves are entirely disqualified, the absolute minimum requirement to build a valid polygon is exactly 3 straight lines.
A moment of wonder. Snap that third line into place, and you've trapped space for the very first time. You've just built the triangle. It is the atomic unit of all geometry, and no complex geometric structure can exist without it. This diagram highlights internal angles totaling exactly 180 degrees. Lock all 3 sides identical to form an equilateral triangle with 60-degree angles. Stretch one side to morph into an isosceles triangle. Distort all sides randomly for a scaling triangle. They always total 180 degrees. We can also categorize triangles strictly by their corners. Force one corner to a rigid 90-degree right angle, and you get a right-angled triangle, powering advanced trigonometry. Squeeze those angles below 90 degrees, and you have an acute triangle. Stretch one corner far past the 90-degree mark, and you've built an obtuse triangle. A triangle is a highly flexible matrix of side lengths and corner angles, morphing and shifting, but always trapped inside that inescapable 180-degree limit. Watch the structural chaos when we inject a 4th straight line into this locked system. The boundaries break wide open to accommodate the new geometry. This expanded 4-sided space is a quadrilateral, also known as a chaturbuj. With this 4th side, interior angles now total exactly 360 degrees. Prove this by drawing a diagonal line, slicing the shape into 2 triangles. The 180 degrees of the top shape simply add to the 180 degrees of the bottom shape. That means a quadrilateral is not some entirely new alien shape. It is literally just 2 fundamental triangles bound together at the seams, proving that the triangle's core logic dictates everything above it. Start with a square, 4 identical sides and 90-degree corners. Drag sides outward to create a rectangle. Lean the frame, forming a parallelogram. Compress sides for a rhombus. Skew side lengths, preserving one parallel pair for a trapezium. The vast diversity of 4-sided shapes isn't random. It's a mechanical process of locking, unlocking, or tilting parallel lines, side lengths, and angle degrees. When we look at this glowing architectural wireframe, we see these abstract rules defining a physical structure. These lines define the stress points and load paths of every skyscraper and bridge. Geometry functions as an interconnected ecosystem of evolving rules, where every shape reacts mathematically to its neighbors. Because the triangle is the only shape that cannot be deformed without changing its side lengths, it provides the structural stability for every complex polygon that follows. Whether it's a crane's lattice or a bridge's truss, engineers use these side length and angle constraints to predict exactly how a structure will hold weight before the first beam is ever placed. These polygons provide the logic required to calculate the limits of physical space. Once you understand how a triangle balances its 180 degrees, you understand the geometry of the built world.